In this animation, I'll be talking about the process of the electron transport chain. This process occurs in the mitochondria and helps us produce ATP. Now, I'll introduce you to the key players involved in the process. Phospholipids, FMN proton pump, coenzyme Q, proton pump 2, hydrogen ions, cytochrome C, proton pump 3, and the last but not the least is the ATPase. An electron carrier molecule, the NADH, passes two of its electrons to the FMN proton pump and becomes NAD+. Meanwhile, a proton is moved from the matrix into the intramembrane space. The electrons then move on to coenzyme Q and then further on to proton pump 2. Again, a proton is released into the intramembrane space at this point. The electrons move on to cytochrome C and then to the third proton pump. Oxygen acts as the final electron acceptor. Oxygen becomes O2 negative and then further combines with two hydrogen ions to become water. Another proton is moved into the intramembrane space at the third proton pump. The transfer of protons from the matrix into the intramembrane space leads to the development of an electrochemical gradient. Now, the protons that were released into the intramembrane space must go back into the matrix, and this can only happen through the ATPase. As the protons enter the matrix through the ATPase, the released energy is used to phosphorylate an ADP molecule and a free phosphate to make ATP. Three protons re-enter into the matrix and hence three ATPs are produced. As NADH is transferring its electrons and as ATP is being produced, there's also another electron carrier molecule that does a similar job alongside NADH, which is the FADH2. Now let's see how that process happens. The FADH2 passes two of its electrons to coenzyme Q and is oxidized to FAD. The electrons move on to proton pump 2. A hydrogen ion is also released from the matrix into the intramembrane space. The electrons further move on to cytochrome C and then to proton pump 3. Again, oxygen acts as the final electron acceptor and a proton is moved from the matrix into the intramembrane space. An electrochemical gradient is established yet again. The only difference is that only two protons were released into the intramembrane space this time. The protons enter back into the matrix and the released energy is used to produce ATP through oxidative phosphorylation as mentioned before. Only two ATPs are made in case of FADH2, and that's how the process happens. Now let's look at the products produced through the electron transport chain. For every one glucose molecule, there are 10 NADH molecules that are involved in the electron transport chain. Every NADH molecule produces 3 ATPs. Hence, a total of 30 ATPs are produced by the NADH molecules. For every one glucose molecule, there are 2 FADH2 molecules that are involved in the electron transport chain. Every FADH2 molecule produces 2 ATPs. Hence, a total of 4 ATPs are produced by the FADH2 molecules. Therefore, a total of 34 ATPs are produced for every one molecule of glucose in the electron transport chain.